அந்த இது எடுங்க இருக்குதான்னு பாருங்க. கிளிக் பண்ண recording. Recording ஆயிட்டு இருக்கு. ரெக்கார்ட் ஆயிட்டு. எவ்வளவு ஸ்டார்ட் பண்ணிட்டீங்களா இல்ல? இதுதான் அங்க ரெக்கார்ட் ஆயிருக்கு. தெரியுது. அதான் ரெக்கார்டிங் ப்ரோக்ராம்.
Yes, good evening to everyone. Shall we start?
Good evening.
Yes, good evening. Okay. Last class we are discussing about the transformers. Now we are discussing about the transient response, steady state response and transient response. So today we are discussing about RL transient circuit, RC transient circuits, RLC transient filters, wave shaping circuits. If time permits, we go to the DC motors. And before that, today, due to some personal work, I will close the session at 10 o'clock, 10 or 10:15. Now we start with RL. We are discussing about the AC fundamentals. We are discussing about AC. We are discussing oral series circuit. The difference between the earlier and here, the only difference here, I am using the switch. In general, the circuit, we have R and L connected with a DC source. So this is the RL series circuit with a DC input. Now I introduce one switch. So when the circuit like this, we call this circuit as a transient circuit, because at t is equal to 0, the circuit behaves at t is equal to 0, at t is equal to infinity, and during this period. During this period, how the RL circuit behave. So these are the topics we are discussing today. So RL series circuit consists of basic inductor L and resistance R connected in series with a switch. So first condition here, due to a problem, a few seconds the system is cold. So, 1 second. The switch S is open at a T is equal to, that is, we are discussing about T is equal to 0 and T is equal to 0 plus. So 0 plus means on condition. How the circuit behave during this period. So for RL circuit, I begins to flow through the circuit but does not rise rapidly to its maximum value. For example, for a resistive circuit, at the instant when switch is on, at the instant the current will flow like this. But for RLC circuit, the graph like this. So initially there is, so this is due to the presence of the inductance. So that behavior we are studying in that RLC transient circuits. So from this circuit diagram, from this we have the two elements, resistance and inductance. Voltage across resistance is VR, voltage across the inductance VL. So by using Kirchhoff's voltage law, the applied voltage VT is equal to, that is Kirchhoff's voltage law is V in is equal to V out. V in supply voltage, V out, we have two elements are there. So first element is resistance, second element is inductance. So that we write here. So applied voltage Vt minus VR minus VL is equal to 0. From Ohm's law, voltage drop in the resistance is VR, which is equal to I into R. From Faraday's law, VL, which is equal to L into di by dt. So this is equation number. This is equation number 1. This is equation number 2, 3. So substitute the equation 2 plus 3 in 1. Substitute 2 and 3 in 1. We get Vt, which is equal to IR plus L into di by dt. This is a differential equation. So this equation is solved. Vt, which is equal to 1 into. So this equation, we solve the equation. We get IR is equal to V by R into 1 minus e to the power of minus R T divided by L. 1 minus E minus R by L hold the bracket into T. So this equation is too important. Using this equation, we solve some problems. So for RL circuit, the transient current, that is the current flow through the inductor at a t is equal to 0 to t is equal to 0 plus, that is infinity. During this period, the current is V by R into 1 minus e to the power of minus R by L into T.
Hello?
Yes, sir.
Hello?
Yes, sir. Hello. Tell me, sir. Yes, tell me, Mr. Redmi. Hello. Yes, tell me, sir. Once again, tell me, sir.
Maybe he's not there, sir.
So I need to mute. Okay.
Yes.
Okay. All the persons are mute. Okay, I mute all the persons. So now we have the final equation. This is too important. So from this equation, To solving the UTC equation, we get solving this equation, we get the I of t, which is equal to v by r 1 minus e to the power of minus r by l into t. This is the final equation that we call as a transient current. Now see this. So we have a equation v by r 1 minus e minus open the bracket r by l t. So this is the equation for I of t. Okay. Now, so substitute t is equal to 0. So substitute t is equal to 0, which gives e to the power of, which gives e to the power of minus 0, which is equal to anything over 0 is equal to 1. So I of t is equal to 0, which is equal to v by r one minus 1. E power 0 is equal to, so at t is equal to 0, the current is equal to 0. So which means that whether the switch is open condition, there is no current flow. Point number 1. Number 2, suppose if t is equal to infinity, so in t for infinity means steady state. Steady state. So t is equal to 0, e to the power of, substitute t is equal to 0 in the this value. So e to the power of minus infinity, which gives 0. So substitute this value in this equation. I t of infinity is equal to v by r 1 minus formula v by r, open the bracket, 1 minus e to the power of infinity gives 0, so 0. So which is equal to v by r. So from this, at t is equal to 0, t is equal to 0, I of t is equal to 0, t is equal to infinity means I of t is equal to v by r. So that's here we mentioned that this is a steady state value. Here we have I max, so which is equal to v by r. So here we have an infinity. So here I say that infinity, but in general it is possible to find the exact value of the t. So in general, t at t is equal to 5 tau, 5 time constant, it achieves the steady state. So here we mentioned that. So it's too important. They ask the question at phi is equal to, at 5 tau, the circuit reaches the steady state value, or we call it a transient period. Just we will discuss in the next slides. So once again, to achieve the maximum steady state, we must achieve the phi t. Phi t means 5 tau. Tau is a time constant. Time constant tau is equal to L by R. Once again, we must by heart this equation. Tau is equal to L by R. So from this equation, first we find that time constant tau is equal to L by R formula. Number one equation V by R 1 minus e to the power of minus just a minute. First point, V by current I of t is equal to V by R 1 minus e to the power of minus R by L T. This is the first equation. Second, tau is equal to L by R. It's another formula. So we can able to rewrite this equation one like this. Because if you refer some other books, they write like this: V by R 1 minus R by L. Here L is equal to tau is equal to L by R, which gives 1 by tau is equal to R by L. R by L. So we can able to write e to the power of minus T by tau. So sometimes some of the books they refer this equation, some book they refer this equation. And fourth one, at 5t that is 5 tau. 5 tau achieves the steady state value. Steady state. Here they mention that t is equal to 2t, 3t, 4t, 5t, here 1t. That is 1t means 1 tau. So sometimes we must remember these values also. At time constant 1, that is at tau, time constant 1, tau is equal to 1, the transient current is 63% as the maximum value. So we have some problems. A coil which has an inductance of 40 millihenry and a resistance of 2 ohm is connected together to form a series circuit. If they connected to a 20 volt DC supply, what will be the final steady state value of the current? So we have a formula for steady state. I is equal to V by R. Actual formula is V by R 1 minus so The question is final steady state. Final steady state means phi t or infinity. So in general, we say the infinity for exact value is a phi t, which is a substitute phi t, it gives the 99.99%. So simple formula is substitute for infinity, we get V by R. So we have the answer like this. So steady state current I is equal to V by R, V is equal to 20 volt, resistance to 2. So 20 by 2, 10 amps is the answer. Hello? Yes, sir.
Yes, so can you get back to the question? Okay, if it is steady state, then the value will be 5 tau or infinity, correct?
Yes. General exact time is 5t. Okay.
Okay.
But in general, above 5t, it has an infinity. So for this particular problem, we substitute infinity for the t. Just use the calculator. Simple thing. If you have a calculator, just do it. V by R, formula is V by R 1 minus e to the power of minus R by L into T. Okay, this is the general equation.
Yeah, this is fine.
This is equation, which is equal to, I rewrite this equation like this: E by R 1 minus e to the power of minus T divided by tau.
Okay, fine.
Now, first step, we find the tau. Tau which is equal to L by R. Okay? L
Okay.
is equal to 40 millihenry. Divided by resistance 2. So we get the tau value 0.02 seconds. Okay. Now,
Okay.
second, this is the first step. Second step, find tau. Because our question of the final steady state. Final steady state is phi tau.
Okay.
So phi tau, which is equal to 5 into 0.02. We have one value. So substitute this value here. That is
Okay.
V by R 1 minus e to the power of minus 100, because just use the calculator. By using this, we find the value. This value to the power of minus 100 gives the 0.000. So almost this value is 0.
Okay.
So that's why we have a simple thumb rule, simple formula. I is equal to first steady state, I is equal to V by R.
Okay, okay, fine, fine.
Okay.
Yeah.
So next question, the same question. Now they ask the what will be the time constant. So formula of time constant for RL circuit, tau L by R, L is equal to 40 millihenry. Just remember that here they give millihenry, you convert. So 40 millihenry can be converted to Henry because unit for the inductance is Henry, not a millihenry. So substitute this value and we get the time constant 20 milliseconds. And read the question. Here you mentioned 0.02 milliseconds. Due to curiosity, sometimes we will select this answer. So it's wrong.
Yes.
Okay.
Yes.
Okay.
Correct.
So next question. Now they ask what will be the transient time of the RLC circuit. This RLC, the transient time, we call as a fighter. So transient time or steady state all are equal. Steady state means t is equal to infinity. Transient time is t is equal to 5 tau. Okay. So e to the power of infinity is used exact value of 0. E to the power of minus 5 tau, which is used 0.00000 like this. But not 1 like this. Okay. So apart from this, here they ask the transient time. Formula is 5 tau. So 5 into 0.02. Already we find that tau in the previous column. That's why I take the answer directly. Okay. Okay.
Oh,
Now they ask the what will be the value of the induced EMF after 10 milliseconds. Once again, this is the question. They ask the induced EMF. So this is the formula for the induced EMF. EMF formula is the current formula. At t is equal to 0, the current is maximum. Sorry, voltage is maximum because draw the graph like this. So we have two curves over there. This curve represents the current. This curve represents the current. This curve represents the voltage. So for the RLC series circuit, at t is equal to 0, at t is equal to 0, I is equal to 0, V is equal to the applied voltage. So here we remember this formula. VL is equal to V e to the power of minus R by LT. I represent here. So formula for induced EMF which is equal to VL, which is equal to V into e to the power of VL is equal to V e to the power of minus R by L into T. This is the formula for the induced EMF. They asked the 10 milliseconds. So this is equal to V e to the power of sorry. So V is equal to 20 volts, 20 into e to the power of minus. So R by L is R, we get 2 L, we get 40 into 10 power minus 3 into 10 milliseconds. 0.001. This is the VL. We substitute this equation, so substitute value, we get the value. And once again, it's too important. Use the calculator. Use system calculator to find e to the power of, because we are failed to use the system calculator. How to find the e to the power of minus 0. E to the power of minus 2 divided by 40% plus minus 0.001. So have a practice. So this is the induced voltage. So due to some reasons, echo is echo. So the problem of 4 and 5 is important. So they may ask the question in 4 or 5. Now the same question they ask, what will be the value of the circuit element, circuit current, one time constant. One time constant, that is
Time constant. Okay.
V by R 1 minus e to the power of minus t by tau. This is the formula. Or V by so tau is equal to, they say that one time constant. So tau is equal to 1. But tau is equal to one time constant. What is the value they ask? Tau is equal to L by R, which is equal to 40 milli divided by 2. First step, we need to find this value. So second step, V by R 1 minus e to the power of T is equal to 1 tau. So that is, which is equal to V by R 1 minus e to the power of minus 1. So e to the power of minus 1, without finding that LR, we can able to solve the problem like this also. So the answer is 6.32 amps. So once again, for this problem, we have similar by using with the system calculator. Next, we go to that RC series circuit. Here, for RC series circuit, we are discussing two different terms two different circuit. One is for RC transient. One is RC charging circuit. Another one is RC discharging circuit. For charging circuit, we apply voltage. For discharging circuit, we remove the voltage source. That's the difference between the charging and discharging. Another thing, for charging, the current direction is like this. For discharging, the direction like this, because the voltage source from source voltage is the capacitor voltage. Let me discuss in that next step. Next step is. So let us assume the capacitor C is fully discharged. That is ideal condition. Assume that the capacitor does not having any voltage, any charge. It's a purely discharged capacitor. And the switch is fully open. That means there is no voltage flow from the voltage source to the capacitor through resistance. So this is the condition, this is the assumptions. So this is our assumptions. T is equal to 0. So current is equal to 0. So fully discharged, there is no charge in the capacitor. Now the switch is closed. When it's at T, that is, once again, at T is equal to close means T is equal to 0. So when switch is closed, the current flow from the voltage source to capacitor by resistance. So since initial voltage across the capacitor is 0, so initially there is no voltage in the capacitor. So later on, the voltage depends upon the capacitor rating, the voltage will charge. So let the free voltage we have two elements are there. One is to VR plus VC. When we solve this equation, the capacitor voltage is, this is important. We must remember this formula. This is similar to the current. When we using RLC circuit, this we must remember the current. When using the RC series circuit, we must remember the voltage. So we must remember this formula: capacitor voltage that is DC is equal to charging voltage. Charging voltage capacitor we call as VC. VC which is equal to Vs into 1 minus e to the power of minus T by RC. Let's assume that T is equal to 0. E power is equal to e power 0, e power of minus 0 is equal to n to the power 0 is equal to 1. So VC is equal to Vs 1 minus 1, which is equal to 0. So which means at T is equal to 0, there is no voltage in the capacitor. So similar to the previous one. First we are discussing about the capacitor charging voltage, the same curve in the RL circuit, they represent the current. Here, we represent the voltage. So initially at t is equal to 0, at t is equal to 0, there is no voltage. There is no voltage in the capacitor. So at t is equal to, t means tau. At tau is equal to 1, it is 0.63 maximum supply voltage. That is, at tau is equal to 1, that is one time constant, it reaches 63%. At the four time constant, it reaches 98%. At the 5 tau, it reaches almost full current. So here we must remember 5t, 4t, 1t, 5t fully charged. Is almost fully charged. Here 63% charge. 0.7t, it is 50% charge. There is no need to buy out this formula. Just you remember 5t is fully charged. That's all. The rest of the equations, by using this formula, by using that, by substitute the value in the equation, we get that 63% and 50%. There is no need to buy out these values. So similarly, at the time, at the t is equal to 0, the current is maximum, and at a steady state, at phi is equal to 0, the current is equal to 0. That we discuss in that next slides. Easy to remember this one. So transient period 4t, steady state period 5t. Sometimes they ask in the number this.
Hello? Hello?
Hello, yes?
Yeah,
Yes, sir.
can you repeat that again? Can you repeat that again for discharging of capacitor?
This one?
Can you repeat it for discharging?
Discharging.
Yes.
No. Now, just that they are discussing about the charging circuit. In the charging circuit, we have two are there. Depends during the charging circuit. During the charging circuit, how? Sorry. During the charging circuit, DC charging voltage and IC charging current. We are discussing about these two things. So the circuit like this. This is a circuit. Okay. This is circuit. At this instance, from this curve, so transient, I think go to the exam problems, you can be able to understand that concept. Once again, I will come back to the concept. Okay.
Okay.
So calculate the time constant tau. I pronounce tau. Some of the book they mention time T, capital T or tau. Okay. So calculate the time constant RC. So time constant formula for the time constant is R by C. For RL circuit, tau is equal to L by R. For RC circuit, tau is equal to RC. So just remember this formula. So here from this circuit, we have R is equal to 47 kilo ohm and capacitor 1000 microfarad. So 47 into 1000 microfarad is the 47 seconds. So this is the time constant for this particular circuit. For the given circuit, find the how much time it takes to fully charge. How much time to take to fully charge? That is 5T. Full charge means at steady state only it is reach the full charge. At steady state means 5 tau. So
Okay.
So fully charge 5T or 5 tau. So first we step, we find the time constant tau, which is equal to formula RC 47 seconds. Already we find the previous one. For full charge, 5 times means 5 time constant. So 5 into 47, 235 seconds. 235 seconds is need to charge the full voltage. Similarly, we can be able to calculate DC, which is equal to DS e to the power of minus P by RC. So this is the formula for the capacitor voltage. DC which is equal to DS e to the power of minus T by RC, which is equal to DS. We have 5 time e to the power of for this. Now we are discussing the problem number 7. DC is equal to VS e to the power minus this is the formula for the charging voltage. So VS is equal to 5 voltage from the circuit. Supply voltage is 5 e to the power of minus P by RC 135. Here already we solved the problem. Remember, they asked the question, how much time it's taken to fully charge? It is 235. Okay, the question is finished. Now we cross check the answer. 5 e to the power of minus 235 use 5. Just you check with the calculator. So next. So already we say that for 235 seconds, it reaches the full voltage. The applied voltage is 5 voltage. So at steady state condition, it is 5 after 235 seconds.
Okay.
Now they ask what is the capacitor voltage after 100 seconds? The question is wrong. We state this value. This is wrong. For a given circuit, find the voltage of the capacitor after 100 seconds. This is the question.
Okay. Okay. Okay.
Formula voltage across charging voltage VC, which is equal to V minus Vs, or V 1 minus e to the power of minus T by RC. Okay. Apply voltage is 5, so I put a 5. 1 formula minus the formula E. Okay. Next we have a T. I put 100. So this is the question paper. They ask the question given data. And RC. RC and constant RC. So substitute this value, we get this. So just we compare the problem 7 and 8.
Hello?
The problem 7 is equal.
1 second. RC is 47, right?
Yes, RC is 47.
Hello, excuse me.
Which is RC is
5 into
basically RC means like 47K into 1000 microfarads.
what's that? Once again, 5. Okay. Open the bracket. 1 minus G formula T minus, open the bracket, T 100 seconds divided by R 47 K into C 1000 micro. So we get the answer. The problem 7, T is equal to 135, capacitor voltage VC is equal to 5. Problem 8, T is equal to 100 seconds, VC is equal to 4.44. Okay. From the problem number 8, at T is equal to 100 seconds, the capacitor charging voltage is 4.44 voltage.
Hello.
Yes, sir.
For charging, this formula VC equals to Vx into 1 minus exponential T over RC.
Yes.
Is that correct?
Yes. This is the formula for the charging current, and we have a different formula for the discharging. We have two formulas are there. One is charging, another is discharging. Okay. Now we are discussing about the charging current, not a discharging current.
Okay.
I think you are this is the discharging current. Discharging Bs into e to the power minus 50 by RC.
Okay, okay,
Bs
okay.
e to the power of T by RC. This is for discharging current.
Okay,
Now we are discussing about charging current.
okay, okay.
Okay.
Okay, that's right.
Okay. And once again, compare with this problem number 7. They say that fully charged. Once again, see the question. Supply voltage is 5 voltage. We have a capacitor. At fully charged, what is the voltage in the capacitor? Just see the circuit diagram. See the circuit diagram. Initially, the capacitor is here, fully discharged. There is no voltage in the capacitor. Okay. One particular instant, the capacitor is fully charged. That means the supply voltage which is equal to the source voltage. That is fully charged means Vs which is equal to Vs.
DC. Yeah. Yes.
Okay. So
That's good. That's
what
correct.
I have solved for 10 seconds, 100 seconds, it has a 4.5 voltage. For 235 seconds, the voltage is 5 voltage. So time is increases, the voltage also increases. That's I can communicate to you. Now we are discussing about the discharging current. So compare with the previous question. Here we remove the voltage source and short circuit. Now the switch is open condition. So at the switch is open, we have some voltage in the capacitor. If the switch is closed, the capacitor short circuited, so it gives the discharge the voltage through the switch or short circuit. So at that time, the entire voltage stored in the capacitor is discharged through the short circuit path. So it takes some time and content. So this is the formula for the discharging. Vc which is equal to Vs into e to the power of minus T by Rc. So here also we are using Vc, and for charging also we are using Vc. So don't confuse with both the equations. So read the question paper carefully, if whether it is charging or discharging. So Vc is equal to Vs minus, Vs e to the power of minus T by Rc. This is the formula for the discharging circuit. So for this problem, irrespective of the charging or discharging, the time constant, the formula for the time constant is same. So capacitor fully charged with 10 volt. So calculate time constant tau. Tau is equal to formula Rc